The second type of mathematical induction questions are these divisibility ones. So just reading the question, prove by MI, mathematical induction, that 7 to the n minus 1 is divisible by 6 for all positive integers. And again, there's that condition, n is greater than or equal to 1. Just be careful, sometimes n starts at 2 or goes higher, particularly for these ones. Okie dokie, so what do? Same 3 steps. So step 1, do you like my green blackboard? Step 1 is to prove true. Oops. Prove true for n equals 1. So, if I sub in 1, that's 7 to the 1 minus 1, which is 6, divides by 6, and that does equal an integer. We know it's divisible. Oops, wrong colour. Try it again. We know that equals 1. Therefore true for n equals 1. The second step was to assume it's true. Assume true for n equals k and make some sort of statement. So wherever you see an n, we're now going to put a k. So we're going to assume that 7 to the k minus 1 now is divisible by 6. Means we get an integer when we divide. So is divisible by 6, and I'm going to call it m. M, where m is an integer. Okay, and it's this equation we use, just like in the last one we used step 2, it's this equation we use to prove step 3. So generally what we do is, I'm just going to change it, it's 7k minus 1 equals 6m, and that's what we use in step 3. And so step 3 is to prove true for n equals k plus 1, because if we've proven it true for 1, and we also prove it now true for n equals k plus 1, then it's true for any integer. So the statement, what we want to prove that 7 to the k plus 1, whoops, to the k plus 1 minus 1 is divisible by 6. Which means if it's divisible, then it divides evenly by 6, no remainders. That's what it means. Okie dokie, so what we've got is 7 to the k plus 1 minus 1. If we simplify that, because we've got to use a part from part 2, that's 7 to the k times 7 to the 1 minus 1. If we fill it out. Now 7 to the k, what we did on the other page, the little assumption bit, I might just write it as an asterisk right here, was that 7 to the k minus 1 equals 6m. That's what we're going to use. So we have to split this one up. So we've split that up. So remember our indice laws, same base, I add the indices. So that becomes that. And 7k I now replace from this equation here. Okay, so 7 to the k, if we rearrange that equation, is 6m plus 1 times it by 7 minus 1. So if I come down here and expand that bracket out, that's 42m plus 7 minus 1, which is 42m plus 6. Now this is what we need to show is divisible by 6. Well, if I take 6 out as a common factor, okay, and then I've got I've got two things that are being times together. I've got 6, well that's divisible by 6, and I've got 7m plus 1. Okay, so what I want to show is that, so your question is 6 to the 7m plus 1, can I divide that by 6? Okay, well I can. 6 divided by 6, that's gone. So that's okay. The question is this an integer? Because for divisibility, it has to be an integer, doesn't it? Well, this is an integer because the way we set it up was that m was an integer. So m times 7 is still an integer, and add 1. So therefore you write, therefore, if n equals k plus 1, then 6 to the 7m plus 1 is divisible by 6, as 6 into 7m plus 1 divided by 6 equals 7m plus 1, and this is an integer as m is an integer. And these questions are pretty much the same all the time. So your last step, remember from last time, proven true by mathematical induction is all you need to write. The M. Mathematical induction. So again, we've used step 2. We've used the assumption very much in this. Okay, that helps us to prove it.